So we are the team from Universitat Politècnica de Catalunya. I'm Gerad. I will present the first part of our task, and Miquel will present the second part. So, looking at our system last year, what we assume, and I think all the participants do, is that the text that appear on the video is directly related to the face you detect on the same at the same time. So what we did last year was diarization-based modalities for video and speech, and then using a fashion method, using an ELP system with some constraints to fuse the assignations. And what we wanted to do different in 2016 was to do the same assumption, but not only with the face identity, but also with the speaker. And then use some kind of tracking system instead of using diarization. And not using ELP at all, because it didn't work very well. So for the name detection, we had two baselines provided to us by the organizers. And alone they were not really good. The names were not, I think Paula showed you. But we made a combination of the two methods, and then we implement a filtering using a list of first names and last names in all the languages of the task, which are 4 languages actually. And using this list of first names, last names, and also list of neutral and negative particles that could appear there and could tell us if a detected text was a name of a person or not. And with some constraints that are there, for example, if a negative particle that we know that it doesn't usually appear in front of a name, and we found it, then that detected text was not a name, was not assigned as a name. And then for the face extraction, the detected faces, where we extracted the features using a CNN trained for using a neural network. And then the name assignation was done temporarily, as I said before. When a name was overlapped with a single track, and not several, only a single track, then we assigned that track the name. And after that, we created a Gaussian naive-based binary classifier to classify to make a verification procedure if two faces belong to the same identity or not. And then comparing the feature from two tracks. Comparing the tracks from the tracks that were assigned a name and the track that still didn't have an identity, we could assign each phase a name or not. And now Miquel will explain the speaking and the fashion system.
Okay, so speaker information was extracted using a vector-based speaker plugin system, and this system was implemented as an identification method with a segmentation by classification method. The idea was that for each show, we created a low complexity UVM to create then a T-matrix. This T-matrix will be used for the posterior I-vector extraction. So our idea was to compare different I-vector segments with the segments that had a text name overlaid. So what we did was we used emphasis features, and we extract them from 3-second segments with a half-second shift. And what we did was to extract the cosine distance between these shows and the query shows, and then assign to the segment the query with the better distance. At the same time, what we did is to train a global trend threshold to discard this distance, because could be assignment with a non-target query. So for the full system, starting off with the speaker and the face tracking short leveling, we considered 2 different strategies, and one was the intersection and the other was the union. And our idea was to develop some strategies that match the shots, but at the same time adapt the scoring between the 2 modalities. And in one hand, we have the intersection, but that was the same intersection that we used in the baseline, but with the difference that we average the score between the 2 modalities. And the other was the union, and where instead of discarding the shots where we only have a name, an assignation in speaker tracking or face tracking, what we did was to reduce the score. So these are the experiments we submit. Baseline was the speaker realization based strategy. Baseline was the face tracking and the face detection and tracking with OCR of the baseline, and the baseline interest was the intersection. As you see, both monomodal systems improve the baseline performance by a grid margin. The union strategy has shown a better performance than the intersection one. At the same time, the fusion, if you compare it with the face tracking, does not show a significant performance. And one of our conclusions is by analyzing the results, we believe that failures at text detection was the main factor impacting the final scores. As a feature work, what we are trying to do was to concatenate speaker features and face features to apply some deep learning and use it as a classifier. And thank you so much, that's all.